This is CPE 133. This is experiment 11. What we're going to do in this experiment is design a sequence detector, and of course it's a digital circuit that's going to be controlled by a state machine. The objectives in this experiment are just to get you more used to using state machines to solve digital circuit problems. And so what we're going to do here is design a sequence detector that detects one of two given bit sequences. Now the issue is which sequence it's going to detect is chosen by a button press. In this experiment, only thing you need to do is verify this visually. These are the two sequences that you need to detect here, and which one it's going to detect is based on this button press. Now, one of the things you want to note in there is these sequences are exactly the same, except for that one bit location. This is something that you're going to leverage when you're designing the state machine to use less states and to keep your state diagram. The state machine here is a resetting type, so when it finds the correct sequence, it resets. For this experiment, you are given most of the circuitry required. And so the circuitry here is the sequence detector circuit, but what the sequence detector does is it reads the switches, uses the values on the switches as the sequence to feed to the state machine. So what you're responsible for in this circuit is simply the state machine, and this is the state machine. This is the X input, which is the sequence, and this is the Z output. Essentially, that's how your state machine tells the rest of the circuit that you found the desired sequence. And so these buttons are the same. This is a button that's going to choose the sequence here. Once again, the Z indicates when the circuit is the circuit finds the correct sequence, and you're going to know it finds the correct sequence because it's going to put a cool message on the 7-segment displays, which you see here in the circuit. The idea here is these are the driver signals for the 7-segment displays. Additionally, there's a LED output to show you which bit on the sequence it's currently feeding to the state machine. So it's going to essentially use an LED to indicate which bit in the sequence it's sending over to the state machine. So the constraints in this file are I only use one finite state machine, and of course you're going to minimize the states in the state machine. Okay, notice that the sequences are similar, of course. You're provided with most of the circuit in the sequence detector module. Certainly don't change that. And you're also provided with a working constraints file. That's something you don't want to change either. So this is since most of the circuit's provided for you, you're only responsible for the state machine. So the very first thing you want to do is design the state diagram on a piece of paper. And to assist you in that, for sure, omit the don't care inputs, which is essentially the button inputs for states where it doesn't matter. This really actually cleans up your state diagram quite a bit, makes it easier to encode when you're actually writing the Verilog model for this as well. So the idea is all you're responsible for is the state machine. You drop it into that top level circuit. There's actually a template in there. There's actually an instantiation in the top level circuit, in the sequence detector circuit. You just add the state machine to your project. Make sure the names match too. There's some other notes in the lab report. By all means, go check those out also.